Hey everybody, this is Dr. Z, and starting up this new lecture series here for Web Tutor Online, phys101. As you can see, it's a pretty comprehensive lecture series, so if you cover all these topics and get your information thoroughly, you should be on top of your game at any level in introductory physics, wherever you are. Today we're going to be looking at some of the math involved in this introductory physics. And so, basic quantities, there's a couple of them that you need to know. Length, mass, time, electric current, temperature. Those are the main ones. You also can have amount of substance, which is used in chemistry a lot, and luminous intensity, which I have not seen a lot. Know the symbol for the units. That's important. So, for meters, you have to get the common M, the kg, kilograms, seconds, capital A for ampere, and current, degrees Celsius for Kelvin, capital K for Kelvin, and then mole and candela. Right? You may not have seen all these units before, but as you go through the course and different topics, don't worry, you're going to see them. Like, derived quantities are basically quantities that are made up of more than one of the basic quantities, combination of the basic quantities. The most important thing to know about these derived quantities is how we derive the unit. As you look at the formula for area, you see length by width, both of them being measured in meters, so it's end up being meters by meters, and that's meters squared. And so that's how you get the units. There's a whole host of derived quantities, and you're going to, as you need them as you go along with the course and different topics. One point to note, some derived quantities have their own unique unit. So even though we may work out the combination of basic units, like in this example of work here, so you have kilogram meters squared over second squared. We basically use the joule, which is equivalent to 1 kilogram meters squared per second squared. Right, so that's its own unique unit there. And as you go along the series, you're going to see a lot more derived quantities. Dimensional quantities basically have their units, and the reason why is because units that get cancelled out. So look at Reynolds density here, density of the substance, which is going to be in kilograms per meter cubed, over density of water, which again is also in kilograms per meter cubed. The units get basically cancelled off, so we end up with no units. Standard form. Yeah, this is some more math here. The idea behind standard form is to write things in scientific notation. That's we want one figure before the decimal point. And so, in the case of 5319, we put the decimal point after the 5, and then we need to determine now how many places we need to move this decimal point, and what direction to get it back to the original figure. So in this case, we're moving it 3 places to the right, and so it's going to end up with a positive power. So it ends up with 5.319 by 10 to the third, as opposed to if it was 0.0186. Where we would have 1.86 by 10 to the minus 2, because now we're moving the decimal place 2 places to the left to get it back to the original point. So if we move to the left, it's going to be a negative power. Multiple and submultiples, basically different scales. So you have the kilo and the milli, those are the most important ones that we use all the time. Just imagine 1 kilometer, or kilometer, is equivalent to 1,000 meters. So if I want to convert kilometers to meters, I multiply by 1,000, or basically 10 to the 3. If I want to convert millimeters to meters, I divide by 1,000, or 10 to the minus 3. And so all you need to know is if you're going from a bigger unit to a smaller unit, you need to multiply. If you're going from a smaller unit to a bigger unit, you need to divide. And the multipliers are actually all in that column right next there. So just remember them. Significant figures really important. So point to note, zeros that come before the decimal place, unless they're mixed into a number, they're not significant. So we won't count them. Zeros that come after the decimal place, immediately after the decimal place, not significant again. Once they come mixed into a number, or at the end of the number, they become significant. So only then will they really count. Right? And once we locate, we start counting from the left for our significant figures. We locate the number of significant figures and we look at the number directly after. It's 5 or more, well, we're going to add 1. And so we can fill in zeros for the rest of places once we find those significant figures. For decimal places, look at how much decimal places after the decimal point. And so if it's 2 decimal places, you just look at 2 figures, or 2 places after the point, and you look at the figure that comes after. If it's 5 or more, you add 1. And that's how we do decimal places. Alright, folks, so that's a little bit of a review of the math involved in introductory physics. So remember, look out for us, like us, subscribe us, and just follow us. Look out for the other tutorials. There's a whole bunch of topics coming up in a whole bunch of different areas. Leave us a comment. Let us know what you think. Right? Until then, as I always say, keep reaching for the stars and keep your stick on the ice, people.